We are tasked with simplifying the fourth root of 162x to the fifth. So I'm looking at this in terms of the index being a 4. This is not a square root. This is a fourth root. We can still use factor trees if that's what you're comfortable with, but we are looking for groups of 4 because the index is 4. So 162 is 81 times 2. 81 is 9 times 9. And the 9s can be broken down into 3 times 3. So again, fourth root, I'm looking for groups of 4 from my prime factors. So here's a group of 4 3s. This 2 does not fit into a group of 4, so it's going to remain underneath the fourth root. Because this was a group of 4, I got to bring out a 3. We're going to do something similar with our variables. X to the fifth is really 5 x's. So looking for a group of 4, I found one group of 4, which allows me to bring an x outside of the radical, and there's still a single x left inside the radical. So this simplifies to 3x times the fourth root of 2x. Factor trees are great, but I would not want to sit here and list out all of the x's if this was x to the 50th instead of x to the 5th. Let's think about what that would look like. So the 162 wouldn't change. This would still be 3 with a leftover 2 underneath. But I'm not going to sit here and list out 50 x's. So really what's happening is we're looking for groups of 4. You're asking yourself, how many times does 4 go in to 50? And 4 goes into 50 12 times. Think about it. 4 times 12 is 48. So 4 goes into 50 12 times with 2 left over. Notice the 12 is the exponent on the x that I brought outside the radical. The remainder 2 is the exponent on the x that's underneath. So you can think about that little bit of division to help you when these numbers are really big and you don't want to list things out. Let's try one more. Take a look at this guy. The fifth root of 32x to the 36th. Well, the fifth root of 32, that comes out really nicely, and you can type that in your calculator if you're not sure. But the fifth root of 32 is 2. Now, thinking about my variables, again, I'm not going to list out 36 x's and find groups of 5. So instead, I'm going to think about 5 goes into 36 how many times? Well, 5 goes into 36 7 times. Think about it. 5 times 7 is 35. So 5 goes into 36 7 times. That's then the exponent outside my radical with 1 left over. 5 goes into 36 7 times with 1 left over. And then don't forget that this was a fifth root, so I need a 5 on the index of my final answer. We are looking to multiply these two expressions together. Unlucky for us, we can do that because these are both square roots. If one of them was a cubed root and the other one a square root, that would not work out so well. We would not be able to multiply them together. But since they're both square roots, we got this. So we're going to start actually by multiplying the parts that do not have square roots. So 10x times negative 5 is negative 50x. Then we will multiply what's underneath the square root. So I have 3 times 15, which is 45, and x times x cubed. Remember, we add our exponents when multiplying these together. So x to the first times x cubed is really x to the fourth. If you think about that, here's my x to the first, here's my x cubed. I really end up having 4 x's being multiplied together. So this is pretty good. However, it can be simplified. So I'm going to look at this in terms of, I like factor trees. So 45 is 9 times 5, and 9 is 3 times 3. So I'm going to keep the negative 50x along for the ride. but I just realized that I can break down this 45. Since the index is the invisible 2 on a square root, I'm looking for groups of 2. So here's a pair of 3's, so I'm going to bring out a 3. And I do have this leftover 5, so I'm going to leave a 5 underneath. And then remember, when it comes to variables, you're using your index and asking, how many times does 2 go into 4? Well, 2 goes into 4 2 times with none left over. So there are no x's left underneath the radical. And now I can just kind of clean this up a little bit. So negative 50 times 3 is a negative 150. X to the first times x squared. Again, remember we're adding our exponents. So that gives us x cubed. And then we still have the square root of 5 as well. So in summary, we started by multiplying the parts outside the radicals, 10x times negative 5. Then I multiplied inside the radicals, and then we simplified that as much as we possibly could.